Hey y'all. Today we're going to solve radical equations. So we've been working with radicals, simplifying radicals. Yesterday we saw how to do operations with them. Today we're going to finish up our study of radicals and we're going to take a look at how to solve them. So I've written down 3 steps to help us out here. We're solving a radical equation. Step 1, you need to isolate the radical on one side of the equation by itself. So the square root symbol, the cube root, you need to get that on one side of the equal sign all by itself. Step 2, raise each side of the equation to a power equal to the index of the radical to eliminate the radical. So some things are going to cancel out. And then step 3, we need to check our answers. So we're going to solve it first and then check our results. The reason checking our results is so important is because we might run across something called an extraneous solution. And that means when we take that answer and substitute it back into our original problem, it actually isn't going to work out. So we call that like an extraneous solution. So we're going to go through and do several examples today, and that'll be what we're working on today. So we're going to be solving radical equations. For the most part, they're just like solving a regular equation. What you do to one side, you do to the other side, opposite operations. You're trying to get x by itself, etc. So let's get started. So number 1 down here, 5 equals the square root of x minus 2 minus 1. I'm going to try to keep these steps here so we can see them for the first couple of problems. So step 1 says isolate the radical on one side of the equal sign by itself. So the radical has something else over here first. So we need to add 1 to both sides first. So we're going to add 1, add 1. So that gives me 6 equals the square root of x minus 2. So the first thing we did was we added 1 to both sides. Now, step 2 says raise each side of the equation to a power equal to the index of the radical. Now, this actually is to the 1/2 power. So again, this actually is to the 1/2 power because you can rewrite square roots as fractional exponents. So again, this is to the 1/2 power. The little number on the outside, even though we don't see it, is a 2. So we already know that the opposite of square rooting something is to square. So we're going to square both sides. But the reason we square both sides is because my index on the outside is the number 2. So you raise the problem to what's equal to the index so that it cancels itself out. So 6 squared is 6 times 6. That's 36. Square rooting and squaring cancel each other out. So that's x minus 2. Now we are definitely back into our wheelhouse. Add 2 to both sides. Add 2 to both sides. 38 equals x. So that was our answer for the first one. Number 2, we have the cube root of 3n plus 2 plus 1 equals 0. Again, the cube root of 3n plus 2 plus 1 equals 0. We're trying to get n by itself. So the first thing we need to do is subtract 1 from both sides because I need to get the radical all by itself before I try to undo it. So we need to subtract 1 from both sides. So that gives me the cube root of 3n plus 2 is equal to negative 1. It was positive on this side. You move it over by doing the opposite. So I subtracted 1 from both sides. Now, this is what number 2 is saying. Raise each side of the equation to a power equal to the index. This is the cube root. So 3 is my index on the outside here. So I need to cube both sides. Raise it to the 3rd power. If 4 was on the outside, you raise it to the 4th power. If 5 was on the outside, you raise it to the 5th power. So my index on the outside is the number 3. So cube rooting and cubing cancel each other out. So that gives you 3n plus 2. Negative 1 to the 3rd is negative 1 times negative 1 times negative 1. That is negative 1. From here, we go through and solve our equation. Subtract 2 from both sides. And divide, and we get negative 1. Now, I do also want to just make sure that we check our answer because that's important also. So I'm going to go back and check our first couple of answers. So what this means is we need to take 38, substitute it back into our original problem, and see if it works out. So 5 equals 38 minus 2. and then minus 1. So we are checking this. Excuse me. You absolutely can type this in Desmos, but right now I just wanted to show you I'm taking 38, substituting it back into my problem there and seeing if it works out. So I'm just going to do a little bit of mental math. 38 minus 2 is 36. The square root of 36 is 6, and 6 minus 1 is 5. So since 5 does equal this side of my equation, that means that my answer checks out. And I would be able to do the same thing over here. I would take this negative 1, substitute it into my space right here, and I would do the cube root of 3 times negative 1 plus 2. I would do all that, add 1 to it, and it should give us 0. So I am going to save us a little bit of time here. When I do substitute this back into my problem, it does work out. So we did check our work. So just make sure you take a moment to check your work. I do have a problem coming up in just a little bit where it's not going to work out. So you'll see that that's why it's important to check our answer. All right, let's go through and do some more. All right, number 3, we got the cube root of 3y plus 1 plus 5 equals 0. We need to subtract 5 from both sides. This is being cube rooted, so the opposite of a cube root is to cube both sides. Cube it, raise it to the third, raise it to the third. Cube rooting and cubing cancel each other out, so that gives me 3y plus 1. Negative 5 to the third, you can type that in your calculator. That gives us negative 125. From here, we solve the equation, subtract 1, and divide both sides by 3. I got negative 42. So it does get to a point where it's a regular linear equation that you can go through and solve. All right, let's take a look at number 4. So this is 3 times 5y minus 1 to the 1/3 power equals 2. Now, this is what I was saying verbally back here with problem number 1. If I slide that down for just a minute, this is actually x minus 2 to the 1/2 power. And this is 5y minus 1 to the 1/3 power. I could absolutely rewrite this problem as 3 times the cube root of 5y minus 1 is equal to 2. So what I did, I took it from out of a fractional exponent and wrote it as a radical. So I want you to get comfortable seeing things in different ways, but knowing that they mean the same thing. So this is to the 1/3 power, and as a fractional exponent, I can write it out like this. Regardless, I can go through and solve my equations just like I did the other ones. So I'm going to go through and divide both sides by 3. So this is 3 times all of this. So we need to divide by 3. So that now gives me the cube root of 5y minus 1 equals 2/3. We got a fraction, but that's okay. Don't be scared of the fraction. The opposite of cube rooting is to cube both sides. So now this gives me 5y minus 1. 2/3 to the 3rd power. Type it in a calculator. That's 2/3 times 2/3 times 2/3. That is 8/27. So you can simply type this in the calculator. 2/3 to the 3rd power. It'll give you 8/27. We're going to add 1 to both sides. Again, it's going to get kind of messy. We got fractions, but we got a calculator. Add 1, add 1. That's going to give me 35/27. And last but not least, the opposite of multiplying by 5 is to divide by 5. So it does get a little messy, but you can use Desmos to help you with your numbers and your calculations with the fractions. All right, now I believe I got a problem coming up that is not going to work out on purpose because I wanted to still make sure you understand this idea of checking your answer. So I'm going to take the number that we get for the next problem and you'll see what I mean about this idea about an extraneous solution. So let me, it's going to be this one. So let's take a look at this one. All right, this one's going to be a little longer than the other ones we did. So we have the square root of x plus 15 is equal to 5 plus the square root of x. The first thing we need to do is get rid. We got 2 square roots for this problem, so make a little note that this problem is different than the other ones because I have a square root on both sides. So we need to start by trying to get rid of the square root. So we're going to square both sides. So I'm going to square this side to get rid of the square root, and I'm going to square this side to get rid of the square root. Now, square rooting and squaring will cancel out this side, so I'm left with x plus 15. On this side, I'm going to need to do the box method or distributive property because I'm doing 5 plus the square root of x times 5 plus the square root of x. So we're doing 5 plus the square root of x times 5 plus the square root of x. This is not 5 times 5 and the square root of x times the square root of x. When you square something, you multiply it by itself. So we're going to have to go through and do some work. So somewhere off to the side, probably over here, I'm going to go ahead and set up my box method. If you prefer to do the distributive property, there's nothing wrong with that. But I'm going to go through and I'm going to go ahead and set up my box method over here off to the side. So here we go. 5 times 5, that gives me 25. 5 times the square root of x is 5 square roots of x. 5 times the square root of x again is another 5 square roots of x. And the square root of x times the square root of x is the square root of x squared. And the square root of x squared is x. So when you multiply square roots, they cancel out and you're only left with what's on the inside, which is x. Now let's see if I can keep that there and put that back into my problem. So I'm going to bring down the x plus 15. All right, this, when I multiply this out, gives me, and combine like terms over here, gives me 25. These are like terms, what I just circled there. So these two are like terms. 5 plus 5, that gives me 10 square roots of x. And I have this regular x that I just bring down. So as you see already, this problem is a lot longer than the other ones because I had square roots on both sides of the problem of the equal sign. So the square root only canceled on the left side, but it did not cancel on the right side. Now I can go through and we're still trying to get x by itself, but I have multiple x's. Anytime in math you have the same thing on opposite sides, they're going to cancel. So I got an x here and I got an x here that I can go ahead and cross out. So now I'm left with 15 equals 25 plus 10 square roots of x. From here, it's positive 25. I'm going to subtract 25 from both sides. So subtract 25, that's going to give me negative 10 equals 10 square roots of x. And we're just going to keep right on going. From here, the opposite of multiplying by 10 is to divide by 10. So that gives me negative 1 equals the square root of x. And I need to square both sides. So I'm going to square this side and square this side. So we get 1 equals x. So allegedly, this is our answer. But the important thing here is that we need to check our answer. So that's the important part, to check our answer. So I'm going to take 1 and plug it back in, and then we'll see what happens. So we're going to check our answer. I'm going to take the number 1, substitute it back in for x here, substitute it back in for x here, and then if both sides equal the same thing, that means my answer is 1. If both sides do not equal the same thing, then this is an extraneous solution. So on the left-hand side, I have 1 plus 15 is equal to 5 plus the square root of 1. So I took 1, I plugged it in here, and I took 1 and I plugged it in here. Now on this side, I'm going to get 1 plus 15, which is 16, and the square root of 16 is 4. On this side, I get 5 plus the square root of 1, and the square root of 1 is 1. So we get 4 equal to 6, which we know is not true. This is not a true statement. So the answer to this problem is no solution. So the answer to this problem is no solution. So it is important to check our answers because we may have an extraneous solution that does not work. All right, let's do one more problem and then you should be good to go. We'll make sure you have plenty of examples here. So we're going to go through one more problem and solve our radical equation. So this is the last one that we're going to do here. We need to get the radical on one side of the equation by itself before I try to do anything else. So we're going to add 4, then work with the 7, and then get rid of the 6 because we got to start by moving what's furthest away from the radical. So we're going to add 4 to both sides. So that's going to give me 7, 6 root of 5m plus 4. And when we add 4 to both sides, I get 14. From here, this is 7 times all of this. So the opposite of multiplying, we need to divide both sides by 7. So this gives me the 6 root of 5m plus 4 equals, divide the left side by 7, it cancels. Divide the right side by 7, we get 2. Now, I need to get rid of my index. The index is the little number on the outside. So the little number is a 6. So I need to raise each side to the 6th power. So we're raising each side to the 6th power so that it can undo this index that's here. So now that cancels. We're left with 5m plus 4. 2 to the 6th power. You can type it in the calculator. That's 64. And from here, we go through and solve our equation. Subtract 4, I get 60. And divide both sides by 5, we get 12. So the answer to this problem is 12. And of course, we check our answer. We would take 12, substitute it back into m right here so we can use a calculator. We would do 7 times the 6th root of 5 times 12 plus 4. Then subtract 4 from it, and we should get 10, which we do. So I'll save us some time there. So this has been a radical equation. So go through, make sure you get the radical on one side, solve your problem, and then make sure you check your answer.